Okay, folks, so the other day we reviewed our dividing rules for exponents with powers, and we did that for a reason, because today we're going to start something with polynomials that's called factoring, okay? So let me explain to you a little bit what that is. First of all, this is a problem that we were doing in this unit, the first part of this unit. We would be multiplying polynomials together. So if I gave you this problem to do, you would take the 3x here, and you would distribute it to each of the terms in that polynomial to get your product, right? So you would do 3x times x squared, which since this is to the first, that would be 3x cubed. 3x times 6x, that'll be 18x to the second. And 3x times 3, which will be 9x. And then this would be your answer that we would give. Right? Okay? Now, what we are going to be doing in this unit, in this part of the unit, is the exact opposite of this. Instead of using the distributive property to multiply the problem out like this, I'm going to give you the final answer. And I want you to, what we call, factor it, to pull out what they have in common and to write the remainder. This is why we practice division, because you're going to need to use division to do this. Okay? So let me give you an example right here. Let's say I give you the polynomial 54x to the fourth plus 6x cubed plus 42x squared. So now notice, well, what do I want you to do with this? Because you can't combine any of these terms. You have x to the fourth, x to the third, x to the second. They're all unlike terms. So what I want you to do is I want you to look at all the terms and look for what they have in common. We call this looking for the GCF, the greatest common factor. So the first thing you want to do is look at the 54, look at the 6, and look at the 42, and figure out what is the biggest number that goes into all three of these. 54, 6, and 42. It's 6. 6 goes into itself, 6 goes into 54, and 6 goes into 42. So that's going to be part of our GCF. Then we look at the x's. Here we have x to the fourth, here we have x to the third, and here we have x to the second. So all of these have two x's in common, because this is x times x, this is x times x times x, and this is x times x times x times x. So all of those terms at least have two x's. So we are going to take that out as the GCF. So you look at the numbers and you say, what's the biggest number that will go into all three of them, which was 6. And then you look at the variables and you say, what do they have in common in regards to the variables? Well, they all have at least two x's in them. So now what you're going to do, this is our GCF. And now what we're going to do is we want to get our remaining polynomial. So what you're going to do is you're going to divide each of these by the GCF. So this is why we practice division. You take each of these terms and you divide it by the GCF that you decided on. So 54 divided by 6 is 9, and x to the fourth divided by x to the second would be x to the second, because I'd subtract the exponents. 6 divided by 6 is 1. And x to the third divided by x to the second will be x to the first. Right? And then 42 divided by 6 is 7. And then x to the seconds cancel out. So there's going to be no x there. So this is our answer in factored form. This is what you're going to leave as an answer. So notice it's kind of the reverse of what we did right here. Our answer here looks like the problem did there. So what we're doing with factoring is we're reversing the distributive property. We're reversing what we were doing before. Okay? So let's do a bunch more problems like this, and we're going to be practicing this for a while. So, let me give you the problem here. We have a trinomial. We want to factor it. So we want to look at what they have in common. So look at the numbers. I got negative 21, I got minus 56, and I got positive 42. What's the biggest number that will go into all three of those? 7. Okay. Now how about with the variables? What do they have in common for variables? This one has an r, this one has an r to the second, but this one does not have a variable. So therefore they don't have any variables in common among all three of them. So you cannot take out a variable as part of the GCF. So 7 is the only thing that they all have in common. These two share an r, but that one doesn't. So the GCF has to be something that all of the terms have in common. So what I'm going to do now is I'm going to divide all three of these by 7 to get my remaining trinomial. So negative 21 divided by 7 is negative 3. And then I've got a minus sign. 56r to the second divided by 7 would be 8r to the second. The variable isn't going to change at all because you're only dividing by the number. And then here it'll be plus 42 divided by 7 is 6. And the r is still going to be there because there was nothing to divide out with it. So this is our final factored answer. And I know it feels a little weird to leave the answer like this because we're so used to distributing, but we're doing the opposite of what we were doing before. Instead of multiplying it out, we're actually pulling it apart. Okay? Let's do a few more. Okay? So here's another one. 12x minus 10x to the third plus 2x to the fourth plus 20. Okay? Now this polynomial has 4 terms, but that doesn't change anything except for the fact that you just have to make sure that your GCF is something that all 4 terms have in common. So you got to look at all the numbers, 12, 10, 2, and 20. And what number will divide into all 4 of those? What's the biggest number that will divide into all 4 of those? 2, right? 2 goes into itself, and 2 divides into all those other numbers. So that is going to be part of our GCF. Now look at the variables. Do they share any variables? Well, this one has an x, and then an x to the third, x to the fourth, x to the second. So they all have at least one x. So that can be part of my GCF. So for the variable part, it's really the smallest variable that they all have in common that you're going to be taking. So that's going to be my GCF. The 2 goes into all of them, and they all have an x. So I'm going to divide all of these by 2x to get my remaining 1, 2, 3, 4, my remaining polynomial. Okay? So 12x divided by 2x, the x's will cancel out and it will just be 6. Minus 10x to the third divided by 2x, that will be 5. And then x to the third divided by x to the first, subtract the exponents, and you're going to get x to the second. Plus 2 divided by 2 is 1, and x to the fourth divided by x to the first, subtract the exponents, and it'll be x to the third. Plus 20 divided by 2 is 10, and x to the second divided by x to the first, subtracts the exponents, and it's x to the first. So that is my factored answer. So you always have the GCF out front, and then you have the remaining polynomial after you divide each of the terms by the GCF. So you're leaving your answer this way. If you multiply it back out, you're just going to get right back to where we started, which is a nice way to check your work, but you want to give the answer in factored form. Okay? All right? And so that's it. Let's do another one here. So let's say I gave you one that had a couple variables. So let's say this has negative 6 So here's a trinomial. And now we have more than one variable. So we just have to pay attention to that. So first let's start with the number. We look at -6, we look at 3, and we look at 6. So what number do they all have in common? What's the biggest number that will divide into all three of them? And the answer is 3, right? 3 goes into 3, and 3 goes into 6. So 3 will be part of our GCF. And then how about with the variables? What do they have in common for the variables? Here you have 7 x's, here you have 6 x's, and here you have 5 x's. So they all have at least 5 x's, x to the 5th. So I'm going to take out x to the 5th because they all have at least x to the 5th in them. And then they all have a single y. So I'm also going to take out a y as my GCF. So you start with the numbers, and then you look at each variable, and you take out whatever it is that they all have in common. Now I am going to do what I've been doing. I'm going to divide each of these by that GCF. To get my remaining polynomial. And my remaining polynomial is always the same size as my original polynomial. So, -6x to the 7th y divided by 3x to the 5th y. -6 divided by 3, that's -2. The y's cancel out completely, and x to the 7th divided by x to the 5th will be x to the 2nd because you subtract the exponents. Here we go. 3 divided by 3 is 1, so this will be +1. Once again, the y's cancel out completely. X to the 6th divided by x to the 5th will just be 1x. And then over here, 6 divided by 3 is 2. The x to the 5ths cancel out completely, and the y's cancel out completely. So all I have at the end of that polynomial is a 2. So this is my final answer. Right there. Done. So it's a little different, and we're going to spend a lot of time practicing this because it's the opposite of what we have been doing. You're taking a polynomial and you're finding the GCF and you're pulling it apart instead of multiplying it out. Okay? All right? Let me give you one to try on your own, and then you're going to do some practice, and we're going to keep working on this next week as well. So don't worry, we're not going to be going away from this. We're going to spend some time on it. Okay? So here's the last one I want you to do. Okay, so this one's got 4 terms. So I want you to pause the video. I want you to take a look at this, find the GCF, and then divide to get your remaining polynomial. Okay? Okay, so if we take a look at this, we have 18, 36, 90, and -9. What number will divide? What's the biggest number that will divide into all 4 of those numbers? It's 9, right? 9 goes into all of them. That's the biggest number that goes in all of them, 9. And how about with variables? X to the 5th, x to the 4th, x to the 3rd, x to the 2nd. They all have at least x to the 2nd, right? So you take out the x to the 2nd because that's the smallest number of variables that they have in common, right? They all have at least x to the 2nd, I should say, okay? So now you're going to divide each of these by 9x to the 2nd. And you're going to get your remaining polynomial, which is going to be 4 terms because there's 4 terms that we started with. So 18 divided by 9 is 2, and x to the 5th divided by x to the 2nd will be x to the 3rd for that first one. Plus 36 divided by 9 is 4, and x to the 4th divided by x to the 2nd is x to the 2nd, right? 90 divided by 9 is 10, and x to the 3rd divided by x to the 2nd will just be x to the 1st. And now this last one is got a minus in between it. 9 divided by 9 is 1, and then the x to the 2nd divided by the x to the 2nd cancels out completely, so there'll be no variable there. But we still have to put the number 1. Because 9 divided by 9 isn't 0, it's 1. And that's it. That's the answer that you should have gotten. You're going to leave it in that form. Okay? So, again, I know this is a little different than what we've been doing, but no big deal. We're going to practice, practice, practice. This is called factoring. You start with the polynomial, you take out GCF that they all have in common, and then you divide to get your remainder. Okay?